Edexcel IAL Chemistry 2025 June, Unit 1, Section B, Question 20. This question is about carbon dioxide. According to data from 2021, there are 415 ppm of carbon dioxide in the atmosphere by volume. Calculate the moles of carbon dioxide present in 1 cubic meter of air at 20 degrees Celsius and 101 kilopascal. The ideal gas equation is given to you. Just make sure that you are applying the values in the appropriate units. You have to convert whatever the units given in different units, alternative units, into standard units in the way that you have to apply in this equation. So we will convert the pressure value into pascals, and I have written it in the form of newtons per square meter. So I can show you that how these values are getting cancelled off. Whenever applying into this kind of an equation, better apply with the units. At the end, you can trace your mistakes. If you don't get the units simplified, then somewhere is wrong in your calculation. So apply with the units. That's something that I always advise to my students. Apply with the units so you don't go wrong. Then volume of carbon dioxide, you can use the fraction given here, the ppm value 415. So you can apply that value and get the volume of carbon dioxide in this amount of air, this volume of air. You can do it by dividing 415 with this value, which is converted, which is a conversion of cubic meters into cubic centimeters. Then you get a volume of 415 into 10 to the power minus 6 in cubic meters. Then R is given already. Then apply the values. Convert T into Kelvin. The relative temperature is given. You have to apply the absolute temperature. Then apply the values. And you can see easily the values are cancelling off. Per Kelvin, Kelvin. Joules into this product, and everything else is getting cancelled off, and you are getting the answer in moles as 0.0172 moles. Part B. Dodecane C12H26, an alkane, is found in kerosene and forms carbon dioxide during its complete combustion. State what is meant by complete combustion. Complete combustion in the sense the oxidation in excess of oxygen. Write a balanced equation for the complete combustion of dodecane and include the state symbols. Your equation should be correctly balanced, and the state symbols also should be given, and you should know dodecane is a liquid because it is having 12 carbon atoms. Question 3. Kerosene is used as an aeroplane fuel. A jet plane can carry a maximum of 800 passengers and uses this much of fuel per hour. Calculate the mass in kilograms of carbon dioxide emitted from the engine per passenger on a full flight from Sydney to Hong Kong. Flight time is 9 hours 15 minutes. First of all, you will have to find the total volume of fuel burnt. Per hour, this jet plane is burning this much of fuel, and that into 9.25, you get the volume of fuel burnt. Then using the density of dodecane, considering that you are allowed to assume that kerosene contains only dodecane, but actually it is a mixture. Major component is dodecane. Therefore, they are asking you to assume kerosene contains only C12H26. So we can calculate the mass of fuel burned in this way and calculate the amount of fuel burnt in moles by uh, multiplying whatever the mass, dividing whatever the mass using whatever the mass by molar mass of dodecane. Then by stoichiometry of the balanced chemical equation that you have done, you get the stoichiometry between dodecane and carbon dioxide as 1 to 12. So multiply whatever this value by 12. Then carbon dioxide produced. Amount of carbon dioxide in moles produced during the journey is this much. That into mass of carbon dioxide, molar mass of carbon dioxide, you get the mass of carbon dioxide per journey, and per passenger divide this value by 800. So when you solve this equation, you are getting 307 kilograms per person. Stop traveling. The formula dodecane represents many isomers, including still 6 diethyl octanes. The names of 4 of these diethyl octanes are given. So, if you draw these structures, you can see that all the possible 3-ethyl compounds are taken. So, we have to switch to the 4-ethyl possibilities. So, 4 diethyl structure is one isomer, and the next isomer will be 4 and 5 diethyl octane.